Hi everyone, today we got a short lesson on saturation and dissolving. So, three kinds of solutions. Saturated means that you dissolved as much as you can at a given temperature. So if you're trying to visualize this, right, if you have a saturated solution, which we have here, if you've dissolved the maximum amount, then you may have some leftover solute. Okay? On the other hand, an unsaturated solution is one where you can still dissolve more, right? It's not quite at the level of the maximum. So you wouldn't have any leftover solute. It would be completely dissolved. Lastly, we have supersaturated solutions, which contain more solute that's possible to be dissolved. And this is only temporary, so one way to do that is to warm your solvent to heat it up. And so that'll allow you to dissolve more than possible, but when it cools down, you may form some crystals, since you're trying to dissolve more than what's possible. Okay? Next, we're going to be able to read a solubility curve. So basically, the line here will tell you the saturated amount, or the max that can normally dissolve. Okay? If you dissolve less than that, then it's unsaturated. So anything below that would be unsaturated. And if you were able to dissolve more than that amount, then it's what we consider supersaturated. So, let's look at an example here. If we have a solubility curve like this, how much potassium chloride dissolves at 10 Celsius? So temperature is on the x-axis here. So we're going to take the temperature, and we're just going to follow it up and see where it hits that line. So you tell me, how much of this KCl can dissolve at 10 Celsius? Okay, next. So we'll see that it is 30 grams. At 30 Celsius, 10 grams dissolves. So that's down here. And it's asking, is it unsaturated, saturated, or supersaturated? So remember, below the line is unsaturated, on the line is saturated, above that line, supersaturated. So here, we're saying at 30 degrees, only 10 grams of this stuff dissolves. Which one of these three options do you think it is? Unsaturated is correct. Lastly, 50 grams of potassium chloride is dissolved at 10 Celsius. How much actually dissolves? So we should really say is mixed at 10 Celsius. How much is actually dissolves, and how much remains undissolved? So we know from the previous question, right, that at 10 degrees Celsius, 30 grams is the maximum that can dissolve. So how much do you think would be left over if we had 50 grams? What do you think? We know 30 grams dissolves. How much would be left over? You'd have 20 grams left over, right? Because only 30 grams, that's the maximum amount that can dissolve. How can we increase the rate of dissolving? So one thing to keep in mind is that dissolving occurs on the surface, where a solvent actually makes contact with a solute. So you actually probably know some ways to increase the rate of dissolving. Here I'm going to use hot chocolate as an example. So one way to increase dissolving is to increase temperature, right? And what that does is particles are going to be moving faster, and thus they're going to be able to make contact with the solute more often. So solvent and solute actually, make contact more often, thus dissolving a little faster. Mixing and stirring, same thing. It's all about making the solvent and solute, right, interact with one another. And so by mixing and stirring, we get a lot more of those interactions. Lastly, we can increase the surface area. And so what that means is if you have smaller pieces, it's easier to dissolve something. It actually has greater surface area when you break something up. So compared to this big chunky hot chocolate here, right, this would take a lot longer to dissolve compared to its powdered form, which we have here. So that's what we call increasing the surface area. All right, and that's it for today's lesson.